Alright, this video is on more basic antiderivatives, and in the previous one we went over a lot of the basic antiderivatives just being reverses of the derivative rules that we know. So these are some we didn't hit in that original video. And so the first one is the integral of secant squared x, and then again the dx is part of this notation. So the integral of secant squared, you got to think what was the function that gave us that as a derivative. And that is tangent x plus c. Our second rule, you have to think what is negative cosecant cotangent the derivative of. And that would be cosecant x. And again, I have that plus c because there could have been a number that we took the derivative of that became a 0. So the plus c is important, don't forget it. Next one, secant tangent is the derivative of secant x plus c. The next one, negative cosecant squared, that would be the derivative of cotangent x plus c. Okay, then I threw in a couple of those arc-trig rules. These look like they're really complicated if you first glance at them, but they're actually some of your arc-trig rules. I'm using the two kind of most popular ones, although it could be the integral of any of your arc-trig functions. So if you think about 1 over 1 plus x squared, that is the derivative of arctan x plus c, and then 1 over the square root of 1 minus x squared should also be familiar as the derivative of arcsine x plus c. And then finally I want to address the a to the x rule on this video. When we took the derivative we did a to the x times the natural log of the base, and so when you're going backwards you do the opposite of that. We would do a to the x times or divided by the natural log of the base, or times 1 over the natural log, because that would be the same thing. So just think about backwards from what you would do with derivatives. But anytime you have the a to the x rule, you repeat that first. It's just, do you multiply by the natural log of the base or divide by it? When you are taking the derivative, you're multiplying. When you are taking the antiderivative, you divide. So these are the two ways you could see it written. Again, you're repeating a to the x and then either multiplying by 1 over the natural log of a, or a to the x divided by natural log of a, because those two actually are the same thing. They're mathematically equivalent. Both of them you have plus c. So just pick whichever way you like, and I'll be happy with that. Let's move on to some examples. Our first example is an a to the x rule. So here we have 2 to the x. So again, the first thing you do is repeat it, and then you can multiply by 1 over the natural log of the base, which would be dividing by the natural log of the base. Or you could say 2 to the x and then put that natural log 2 on the bottom plus c. So that would be your basic a to the x reversal from a derivative to the antiderivative. Now our next group of problems are going to make us remember some of our trig identities, because I did say this is basic antiderivatives, so none of them get crazy complicated, but you are expected to remember how to use algebra to simplify things and how to use trig identities to simplify things. And since in the first video I did more algebra, here I'm going to do some trig identities to refresh your memory. The first thing is secant is on the bottom here. You really have 1 over secant, which is the same as cosine. There is that reciprocal identity that you learned, that 1 over secant is cosine. Now, the biggest mistake that some people make is they bring the 4 with it. It's not 4 cosine. The 4 is a number. There's no problem with that. It's on the bottom of a fraction, so that is 1/4. So this problem can be rewritten as 1/4 cosine x dx. And then you just bring the 1/4 over or down, however you're writing, and think what is the antiderivative of cosine, and that would be sine. Don't forget your plus c. The next example, 1 over sine squared. So a similar situation, we're using that reciprocal relationship. 1 over sine is cosecant. So I can turn this into cosecant squared because the sine was squared. And since my variable is t, I need a dt for the notation to be correct. And then I think, what is the antiderivative of cosecant squared? What gives me cosecant squared as a derivative? And that is negative cotangent. Now, you know, if you have your derivatives memorized, you probably memorized cotangent. The derivative of cotangent is negative cosecant squared. So you have to think about that. If this was positive and you're going backwards, you're going to need a negative in front of that to balance out that rule. So again, here is our answer, negative cotangent t plus c. Now, example 4 should remind you of some of those problems we did when I taught you the trig identities, your basic trig identities. And anytime you see something like this, we're going to turn things into sine and cosine. You will use a lot of those reciprocal identities to do that. Here, cosecant is 1 over sine. Cotangent is cosine over sine. And secant is 1 over cosine. And I can cancel out those cosines and end up with 2 sines on the bottom, so that would be 1 over sine squared. So if I rewrite this problem, 1 over sine squared, that's the same problem I just did in example 3, so I know that that becomes the integral of cosecant squared, and the antiderivative of that would be negative cotangent. And then finally, number 5, again, is something that looks really complicated, but you can think of it some different ways. The best way here is to realize that you have sine over cosine, which is a reciprocal identity, a fraction that you probably memorized with those reciprocal identities, where that is tangent. Sine over cosine is tangent. So I'm going to turn this problem into secant, because I didn't mess with that, times tangent. And you'll notice that that is one of your rules. So the derivative of secant is secant tangent, and so if I'm doing the antiderivative of secant tangent, I should just get secant. So secant plus c. So here's my answer for that. I forgot to circle my answer up here. And so all of your rules should either be basic, I look at the rule, I know the answer, or I can do some algebra or a trig identity to simplify. And that concludes this lesson.